Yes, thank you, Ashley. My name is Clayton Pettmiller. Again, I'm a solution engineer with Hagerman and Company. The topic of discussion today, as you guys saw in the little bio, is Autodesk HSM, specifically the Inventor CAM portion. I'm going to try to clear up a little bit of confusion in the market about the naming conventions. With that being said, this is pretty much all about Autodesk HSM. If you're wondering about the labeling, HSM is basically short for high-speed machining. I know more and more machine shops are getting into the high-speed machining tools. So the product name to accommodate and let people know that we can handle the high-speed machines is Autodesk HSM. Part of HSM, one big bonus of the HSM is we have a belief that design and manufacturing should be part of one overall seamless workflow. You should not have to go through several different softwares and several different steps to machine the products that you're making. You should be able to design and manufacture all in one seamless workflow. Technically, all in one product as far as that goes. Now, one of the benefits to having it all integrated, and I'll kind of talk about this slide here a second. In normal traditional CAM systems, just to give a little bit of my background, I've worked in about 8 different CAM softwares. I have seen quite a variety in the market. They all do behave a little differently. They all have different capabilities. I like the integrated portion of Inventor HSM because on a traditional workflow, you've got somebody, first square here in this dialog, creating CAD data. That could be a CAD designer, it could be an engineer, it could be basically anybody creating CAD data. It could even be the machinist creating CAD data. But generally the first step is to create some sort of CAD data. What are you going to machine? In the traditional stages, where I used to work is a great example. I would take my CAD data and export it into a neutral format. Step, SAT, or some neutral format. Over on the machining software, I used to work with like SmartCam and SurfCam. You would take that CAD data and import it into your machining software. Of course, you define your job setup. You define whatever machining operations you're going to do. You generate toolpaths. You might even go through as far as verifying that toolpath. Then you would post out the G-code for the machine. That was the traditional, what we call the 8-step process. Of course, eventually, as we all know, we all live in the real world, things do change. If you work in a company where things never change, I'd call you very fortunate because we all know things change. Now, with the traditional system, what would happen is if the part got changed, the CAD guy would open up the CAD file and make the updates. He'd have to re-export it. The CAM guy would have to re-import it. Of course, once you import the data a second time, it sees it as new data. So you got to redefine your job setup, redefine your operations, generate more toolpath, verify your toolpath, and again, post code. That was the traditional way of doing things. With Inventor HSM, we can eliminate a good half of these steps. With integrated CAM systems like Inventor CAM or SolidWorks CAM, I'll talk about that in a second. All you have to do is, on your initial run, create your CAD data. Since your machining software is in your CAD program, you go straight to define setup. So you've eliminated 2 steps of the whole import-export thing. Of course, the rest of it's pretty much the same: define operations, verify toolpath, and eventually post your code. The real benefit is when the model changes or change comes along. All you have to do is open up the model, change the CAD data. You don't have to go through importing, exporting, redefining setups, redefining operations. You just click one button that says regenerate my toolpath to match the new model. Of course, you're probably still going to verify it and you post code. So we can shorten your overall cycle of manipulating CAD data by having your CAM integrated into the product. So, quick summary of some of those benefits. Obviously, your workflow, as you just saw, is definitely streamlined. We put in here simplified data structure because you're not dealing with multiple softwares and multiple file formats and multiple files that have to be saved. It's now one software, one CAD file that you're saving. Obviously, that leads into my third bullet item here, shorter learning curve, because you don't have to relearn a whole new software. You just have to relearn maybe a toolbar to do your machining with. Another benefit, which I didn't think about much until I actually started using CAD-CAM software, is you have full CAD functions prior to machining. I have worked, I mentioned this earlier, about 8 different CAD-CAM systems. Not all of them had CAD capabilities. So if I get ready to do some machining and I have to block off an area with a sketch, or maybe plug some holes that I don't want to drill, or maybe even create some tooling fixtures. If you have CAD functions in your software, you can do that. If you don't, you're kind of just stuck with machining. You have to go ask the CAD guy to put that stuff in. And of course, with Autodesk Inventor, we have a nice little thing called AnyCAD. AnyCAD allows Inventor to open up anyone else's native files. We can just do a file open or file link to SolidWorks, Pro Engineer, CATIA, SDRC, just about every CAD package out there in the world. We don't have to import their data. We just point to it and use it. And we'll kind of talk about that as we go through. So again, as I mentioned before, you can easily fill holes and pockets as needed, create runoffs or addendum data, add additional data to the part, or even model work holding and fixture devices that are going to hold your part. Now, talking about AnyCAD. Most CAD softwares, I've worked with several of those as well, most CAD softwares can import other models. Like we can import a SolidWorks file. We can import a CATIA file. We can import a Pro Engineer file. We can import from just about anywhere. The difference with AnyCAD is you don't have to import the file. You can just link to it. So if you've got a partner using SolidWorks, you just launch your Inventor and say, point to that SolidWorks part, I want to machine it. So it shows up on the screen and you start machining it. Now, if the guy changes that SolidWorks model, your model on the screen is updating because you're just linked to it. You're not actually going through that whole import-export process. So, of course, this webinar is focused on showing you Inventor CAM and how we can machine inside Inventor. I just want to make it perfectly clear that this is not limited to Inventor. We can machine anyone's parts. And if the part changes from any other modeling software, your toolpaths can be associated to it and automatically update with the click of a button. Now, as far as the language goes, you saw the initial slide said Autodesk HSM. Well, that's actually a collection of products. Autodesk HSM is Autodesk High-Speed Machining. Now, for you guys that are out there using Inventor, the product itself is called Autodesk Inventor CAM because it's CAM that runs inside Inventor. They don't really call it Autodesk HSM. It's actually the product name for Inventor is Inventor CAM, which is part of the Autodesk HSM package, the collection of machining softwares. So Autodesk HSM is high-speed machining. What does that incorporate? Well, Inventor CAM for Inventor. If you're using SolidWorks, we don't mind talking about SolidWorks. If you happen to have your SolidWorks as your main CAD program, we can accommodate that. They have a product called HSM Works, high-speed machining for SolidWorks. HSM Works is the product that plugs into SolidWorks. So we've got the Inventor product that plugs into Inventor. We've got the SolidWorks product that plugs into SolidWorks. Now, if you happen to be using another software out there, and I know there's hundreds of them, I'm going to name some of the big ones: SDRC, CATIA, Pro Engineer. There used to be Solid Edge. I'm not sure they're still around anymore. But whatever that CAM pack or CAD package is, we also have a cloud-based Autodesk HSM called Fusion 360. You can take any model into Fusion 360 and do all your machining in the cloud. So even if you don't have Inventor or SolidWorks, we still have a machining package that's going to machine your parts. So those are the three product names: Inventor CAM, HSM Works, and Fusion 360. They're all part of what the overall umbrella is of Autodesk high-speed machining. As far as Inventor CAM, because we are an Autodesk reseller, we do focus on Inventor. There's actually 3 levels of it. They have an Express version. Express is basically 2.5-axis milling. I'll get into specifics on exactly what that entails in a second. And if I remember, and I did not do a fact check before I started this morning, I believe you can still get the Express for free. So if all you do is simple pocket milling and drilling, you can try out the Express anytime you want and see if you like the program. When you start paying for products, there's 2 levels: Premium and Ultimate. Premium is going to do 2.5-axis milling, 3-axis milling, 3-axis milling with A, B, or C positioning. They call it 3+2, where you have a rotary table or a rotary indexer. We can run G-code to turn those indexers and position any way you want in 5-axis. It's not full 5-axis simultaneous motion, but they call it 3+2. It also comes with turning, probing, cutting. A lot of people ask what cutting is. Isn't that milling? Well, nowadays with lasers, plasmas, water jets, those are more classified as cutters rather than millers. So that's kind of what's in the premium package. When you get into the ultimate, which is their highest end, you get everything mentioned above plus your full true 5-axis simultaneous milling. My demo today has one little piece of 5-axis in it, so you get to see that. Now, as far as what's included in each level, 2.5-axis, 2D adaptive clearing, pocket milling, facing, profiling, slotting, tracing, engraving, chamfering, drilling, core threading, circular and thread milling, which handles just about everything but your, what I call the wave contours, where you have like an ocean wave and you're machining up and down, left and right in all different directions at the same time. But you see the parts on the screen there. You've got holes that are being drilled, faces that are being machined, contours that are being cut, pockets that are being done, threading. Your 2.5-axis machining will do a lot of basic parts. 3-axis functions, when you get into more of the contour shape parts, you have adaptive clearing. Horizontal machining, what a lot of softwares call waterline machining. You start at the top and you step down as you machine the shape. All right, I just saw a note that somebody lost their video connection. I wanted to make sure we were not losing the whole thing altogether. So, parallel machining, what's sometimes called lace machining, zigzag back and forth across the part. Contour machining, ramp machining, spirals and more spirals, radial. You can do projections. I try to explain that in training class. I could draw a star above a part and tell the tool to follow that star in 2D, but keep the tool on the part underneath that's moving up and down. They call that projection machining. Morphing machining, scallop machining. We do have pencil tracing, 3+2 machining for multi-axis machines. I'm hoping to show you as much of this as I can. We'll see how the time goes. You get into 5-axis functions. We've got swarf cutting, multi-axis contours, automatic tilting, 4-axis wrapping. A lot of times people have a slot or a groove wrapped around a cylindrical shape. We handle all that. So HSM, even though it's built into Inventor, I wouldn't call it a lightweight machining program. It will machine just about anything you want to throw at it. On the turning side, standard profile, standard grooving, single grooves, plunge grooving. They either do XY groove or XZ grooving or plunge grooving, facing, parting, threading, chamfering, stock transfers for multi-spindle machines, mill turn environments. So you can do milling and turning in one environment. In addition to everything that I showed you in the other slides, there's always the oddball miscellaneous stuff. We do recognize when you machine something, what stock on that part has been removed, that we can say, forget what's been removed, just focus on what's left. That's called rest machining. We do have automatic tool holder collision avoidance. So if you have a particular holder that's holding your tool, we can make sure it doesn't hit anything. That even incorporates custom hand-designed tool holders. Slope-based machining, which will adjust your offsets depending on the slope of the part. It does come with a full CNC program editor. We also have probing, since a lot of machines, part of the setup has to do with probing your part. We also have automatic setup sheets and simulation. There's a simulator built right into the program, so we can simulate and verify your tool paths. So again, a little bit of everything. Why should you try HSM? Adaptive roughing. That's something unique that you're not going to find in any other software. It's a different approach to taking out stock. And I actually have a couple good slides and a couple things that will show this. It comes in simple packaging. I just showed you what they have. They have the Express and the 2 higher levels. You don't have to pay per module. I know there's a lot of softwares out there that's like, oh, you want to do XY machining, that's module A. You want to add Z axis to that, oh, that's module B. Oh, you want to have turning too, well, that's a separate module. Oh, you want to do some laser cutting, well, that's a different module. Oh, you want a simulator, well, that's an extra cost. There are no extra cost modules. What you see is what you get. It is fully associativity with your model because it's in the same platform. If your model updates, your toolpath, again, just one click, update your toolpath. Run where you want to run. We run inside SolidWorks, Inventor, or Fusion. Post-processors. This is a touchy software, or a touchy topic for a lot of softwares. The software I used to work with when I was out in the field, they charged for the program. They charged for each module that you added to your program. And if you decided your company was going to buy a new machine, we had to go pay for another post-processor for that machine. To give you an example, where I worked, we had 9 different machines with 9 different controllers on it. And yes, we had to pay for 9 different post-processors. Every time we bought a machine, we had additional cost. One thing about HSM, they're all included. They have a website on, they actually ship like 75 of them with the program. They've got an online download site that has hundreds of post-processors on it, and there's no charge for any of them. We have a very strong CAM community. We also have online training available through our company, Hagerman & Company. And we also have local resellers throughout the country that can help you get started in this. I'm in the St. Louis area, but we've got people all over the Midwest, East Coast, and West Coast. But adaptive clearing, I wanted to show this slide because sometimes it's easier to show it in a slide than it is in the actual part. The picture on the left is the way a traditional tool, a traditional CAM program would approach a shape. You'll see the tool progresses towards the corner. It actually goes through the corner. When it gets up to the slot, it has to follow that shape around the slot. It just turns the corner and keeps going. But what you end up with is inside the corners, you're increasing your chip load dramatically. When you go around the corner to go down into that slot, you're actually burying the complete tool. So there's no such thing as an easy cut there. You're just going to make the corner, and all of a sudden you're cutting with 100% of the tool as it goes down into the slot, maybe not quite so much coming out. Now, what adaptive clearing does is they kind of pre-read the program. You see the picture on the right? As it approaches that corner, it sees the corner there, and what it's going to do is not dive into the corner, but you'll see it takes a reduced cut. As soon as it clears that corner, it's going to loop back and then cut the rest of that out. So rather than doing that corner as just a into the corner and out, and you've heard all kinds of machine tools squawk when that happens, it'll do it in 2 swipes. So it never completely buries the tool. You'll see the same thing as it enters that pocket. It doesn't just dive into that slot to machine it out. It starts taking it in swarf cuts. So there's an example. It's got 2 cuts drawn in there. It's going to do a swipe, come back, take another swipe. So it's basically doing a larger circle progressing forward. So the advantage of that is, A, you never bury your cutter, which means 2 things. One, since you're not burying the cutter, you're not going to have to adjust your feeds and speeds to run slower. It maintains a constant chip load, so you can keep running at your high speed. Secondly, since you're maintaining that constant chip load, you're also improving your tool life. So your tools are going to last longer, your machine's going to be able to run at higher speeds, and you're maintaining a constant cut. They have this patented. It's kind of a one of a kind. I haven't seen any other software do this approach on roughing, but it definitely will help. So with that being said, keep in mind that Autodesk HSM is the whole family of products. It is all integrated to depending on where your models are coming from. So with that being said, let me get out to the product and start talking a little bit about how HSM works. This was supposed to be a first look seminar. So I wanted to show you what happens when you take a first look at the product. Again, kind of set this up for people that hadn't seen it. If you've seen it before, that's fine. You may pick up on some stuff that you haven't seen before. But I launched Inventor. I can go to File, Open, or I can do my Express Open here. When you open an Inventor part, normally it's going to show up in the model ribbon just showing how the part is built. You can tell this part has several extrusions, a few chamfers, some holes, some fillets, a little bit of everything in this part. Now, depending on where the part comes from, I get parts from customers all the time. Sometimes what you call up is not necessarily up. I am going to show you real quick. You've got a little view cube over here in the corner. I can orient this part to look straight into it. I can look on the side. I can look on the top. I can rotate it around. So the view cube kind of gives you a way to look at the part. This little house up here is what they call the home view. You may want to have the part oriented the way you want to machine it. If you're the machinist, you want to have the part the way you want to look at it, not the way the designer put it on his equipment. So what I'm going to do here is I'm just going to shuffle this around a little bit. I'm going to take this, and I'm just going to call that the front of the part. I'm going to go to this corner, and I'm just going to make that my home view. So just with a couple clicks there, now if I'm rotating the part and I get it all upside down and backwards, I can just tell it to go home, and it's oriented the way I like to see it. Now, normally when you get a part from a customer, again, I could have had a SolidWorks part that was just linked in, or a Pro Engineer part that was linked in. This happens to be a part that was made in Inventor. First thing you want to do is just activate the CAM software. Again, I don't have to save, export, launch something else. I just click on CAM, and there's a CAM ribbon built right into the software. So just like I got my modeling, my sketching, my annotation, I've got CAM. It's just another ribbon inside your Inventor. Now, the first thing you do when you go into CAM is you got to say, okay, how do I want to set this up on the machine? Typical machinist question. How is this going to sit on the machine? Where's my zero? So the first thing you probably want to do is do a setup. You just click one button, and it immediately throws a piece of stock around it. You can choose what kind of machining you're going to do. We've got milling, turning, mill turn, cutting. You kind of saw that in the preview PowerPoint. In this particular part, we're going to do some milling. Orientation, the model orientation, it shows you where the model 0 is. I can leave that where I want it to be, or I can just say, you know what, I want to choose where I want to machine. Let's say I want to machine, let's say you want to machine the front of this for some reason, or maybe the back side. Or let's do this. There is a little pocket on the back side here. Maybe I want to machine the back side of this thing. Okay, so I can be looking at this pocket. Well, obviously, if I'm going to machine the back side, the Z is pointing in the wrong direction. So I just come in here and say, you know what? We'll just grab a Z-axis plane and the X-axis. So like this pocket could be my Z plane. By picking that pocket, it points the Z up. My X-axis could be a straight edge anywhere. So there I've got my X, Y, and Z oriented. And I can choose where I want my 0 to be. So I can put 0 in the middle. I can put it, say, out here on the corner of the stock. You know, I've seen so many different variations of this. I've had companies say, well, we always put our 0 at the bottom left of the part. Okay, fine. Put your 0 at the bottom left. Some people say, well, we put our 0 at the top center. So fine, put it at top center. As you can tell, I'm basically just clicking around the screen, deciding where I want to put my XYZ coordinate system for the machine. As far as the stock goes, different ways to define your stock. You can do a fixed size box, a relative size box. If you're doing turning, a lot of times you're doing fixed or relative size cylinders. We've got tubes if you're doing some turning and it's a hollow part. You can actually choose another solid to use as your stock. So if you machine castings, you can just put the casting in there and say, this is my stock. I kind of like the relative size box because you tell it how much extra you want. So let's say I want a 1/4 inch on the sides. And you can easily tell it just added a 1/4 inch on all 4 sides. This is a relatively small part. Of course, I hit the home button. I'm working on the back side here. You can tell how much you want on the top. You can also tell it if you want any extra stock on the bottom, if you're going to put it into a vise or something underneath. Maybe you want extra stock on the bottom. Whatever numbers you put in, it will tell you what your final size of stock is. It'll even round off for you. If you don't want to buy a piece of stock that's 0.975, you can say, you know what, round off to the nearest 1/8 inch, and it will round off your stock size. So a lot of different ways you can do this. It's also going to ask you for some post-processing questions. Just for right now, I'm going to hit cancel. And I'm going to walk through like we're going to machine the top of the part. See, you get to see it twice. Set this up. Put my 0 over here on the corner. My stock, let's just add a little extra on the sides, quite a bit extra, 1/4 inch on the sides. We'll put 100 thousandths on the top. I'm not going to put anything on the bottom. I really don't need to do anything special on the bottom. Post-processing, I can go ahead and assign it a program number. Program number 1001, program comments. This is my first part. And this is work coordinate system 1. That kind of relates into most machines. Work coordinate system 1 might be G54. Work coordinate system 2 might be G55, G56, G57. They keep it neutral in the program, so you can have different machines running the same part. We used to have a Fanuc-based machine where it was G54, G55, G56. We also had a tree machine with a Dynapath control on it, and it was using EO1, EO2, EO3, and EO4 as fixture offsets. So even though the machines are different, in here, all you have to do is just say it's work offset number 1, 2, 3, or 4. And that also leaves you unlimited. You can have work offset 999. So once you have your setup done, then you're off and ready to machine. So there's my part, there's my stock. I've got a wide variety of tools I can machine with. Let's say I want to do a face mill. Now, what I tell people, to use this product successfully, all you have to do is really do 3 clicks, and I pretty much will guarantee full success every time. Example, let's say I want to face off the top of that stock. I grab the face mill operation. I come in here and I grab a tool. They do have a complete tool library here. Let's say I grab, well, there's 2-inch shell cutter there. I could grab that. This is a smaller part. I think I'm just going to come down here and grab like a, we'll grab a 3/4-inch flat end mill. You can tell it's a pretty good size tool for that. Once you grab a tool and decide what tool you're machining with, just say okay, and it will give you a toolpath. Again, the 3 clicks, I just told it I want to do a face mill. I grab a tool, and you've got a toolpath. Now, the toolpath that shows up is color-coded. They show yellow for your rapid moves, green and blue for your feed moves. The difference between green and blue is engaging or cutting material, green is not. So you can always tell when the center of the tool is in contact with the stock because that's where it changes color. If you want to look at any of this, you can just click simulate, show the piece of stock, hit your little, I call it the VCR button, showing my age, but the DVD button here, just hit play, and you can watch it machine. So there's your verification program. Now, once you have a face mill, again, what I did, 100% straight out of the box. Now, some people say, well, what if you want to change it? The way this program works, one of the easiest programs I've ever learned. I'm not just saying that as a sales guy. I'm saying this program, compared to the other 8 that I've used, is the easiest one I've ever had to learn. They put everything on 5 tabs here. Tab number 1 is your tool. I can click on tool. I can select a tool. Once you select your tool, all the feeds and speeds that come in are based right off the tool you selected. Now, I can change them here if I want. If I want to run that at 10,000 RPM, I can. But the tools come, or the feeds and speeds come from the tool. So if you got your tool library set up, then you really don't have to mess with anything on this page other than selecting your tool. Of course, you got your coolant here as well. So page 1 is all about the tool. Page 2 is what are we machining? This will change depending on your operation, but in a nutshell, since I told it to face mill, it's face milling the stock, so I didn't have to select anything. The 3rd tab has to do with clearances. You have your overall clearance plane. This should be high enough to clear all your clamps or anything that you might have on the screen that you want to make sure you don't run into. Now, you can tell I can move that here on the screen, or I can type in a number. It's your choice. So you got your clearance plane. You've got your retract plane. This is your safety plane or your R plane. It can be hand adjusted. When you get into that retract plane, that is basically the point where it's going to change from rapid to feed. So it's going to rapid down to the safety plane, then feed from there. The light blue one is where it's going to start machining, which is your top of stock. And the dark blue one is where it's going to stop machining, which is basically the top of the model. So you're machining everything between the 2 planes, everything else is clearance planes. But this has to do with the heights of everything. They're all color-coded. How can you go wrong, right? The 4th tab is what I call the control tab. This is where you start getting into the nitty-gritty of what you're machining. So give me an example. Let me just say, okay, I didn't change anything. There's our toolpath. Let's say I don't like how much of that tool is being used for that cut. It's using like 95% of the tool. I just double-click, go to my control page. It's using, by the way, there are defaults here. You can see with that little help flag that comes up, the default for diameter on a flat tool is 95% of the tool. I don't want to use 95% of my tool, especially on a 3/4 inch tool. Let's say I want to step over, let's say, a 1/2 inch. Again, just change it, and you can tell as soon as I say okay, it's making more laps now because it's not doing quite as large a step over. Maybe you don't like the direction that it's doing. And come in here, right now my direction is 0 degrees. Maybe I want it to be at 90 degrees. So maybe I want to lace back and forth the other direction. Maybe I'm concerned about how the stripes look on the top of the part. Maybe you want to get fancy. Just come in here. Say I want to do this at a 45-degree swipe. And you can tell, we'll take a look at the top of it. It's taking it at a 45-degree swipe. I'm just going to set it back to 0 because that's the one that makes more sense. I can even add extra difference on the extensions. Let's say I just want to go an extra 3/4 of an inch off the ends of the part. So now you can see the toolpath is longer on both ends. So as I'm doing my turnaround and stuff, I'm not anywhere near the stock. You have full control of every toolpath that you create. They've got it divided up into these 5 tabs to make things easy to find. Again, the tool, what you selected, your different heights, your control page, and the last one is how things are linked together. You'll see this in a minute when I do these 3 pockets. I can machine all 3 of those pockets, even though they're different depths at the same time. How do you get from pocket A over to pocket B over to pocket C? How do you do your lead ins and lead outs? That kind of stuff. So this is all the linking page. And maybe I want to do multiple depths. You notice it cut all that top with 1 pass. Maybe I want to do multiple depths and take 50 at a time. So if I do that and say okay, you'll notice it's now taking 2 laps instead of 1. I want to simulate that real quick. Hit play. You can see it's not taking near as heavy a cut. When it gets done with the first set of laps, it's going to retract back, take the second pass. So that is an example of how this would work for your machining. Let's go ahead and go in a little bit deeper. I do have some other parts I'm going to bring up and show you more. You know, I'm working on a 2.5 axis part, showing people what you could get with 2.5 axis. I am going to get a little bit deeper here in a minute. But just give you an example. Let's say we want to do some pocket milling. I go to tool. Let's say I grab a smaller tool. I know it's going to take a 3/16 tool to get inside these corners that are in these pockets. So let's say I grab the bottom of that pocket, the bottom of that one, the bottom of that one. So I grab my tool, point to the part to tell it what I'm cutting. When I say okay, there's the toolpath. So you're guaranteed a toolpath every time you click OK after selecting a tool. Now, obviously, I don't want to cut that pocket all in one shot. So I want to make some changes to it. I'll make the changes one at a time so you can see the results. When I'm teaching, I try to get people to do things one step at a time so they can see the results. Eventually, you're going to start changing multiple things. But just give me an example. I double click on the pocket. First thing I want to do is change the tool step over. Since I'm using a 3/16 tool, I'm going to do 100 at a time. So that takes care of how much we're stepping over. You can see I've got more paths in the bottom of those pockets. I'm going to edit that again. I'm going to go to my lead ins and lead outs. It's using a helix entry. I just want to do a plunge entry. You can see now I've just got a straight line plunge instead of that little red coil that was in there. And I think I want to do this with multiple depths. Let me edit that again. Right now, I am leaving stock. I can actually say, you know what, don't leave stock. I want to go ahead and finish. Anything that you uncheck just turns it off. Anything you want to do, just turn it on. I want to do multiple depths, and I want to do, let's say, 100 at a depth, 100 at a time. I do want one finish pass at the bottom to take off the last 10 thousandths. I could type. So now you can see that each pocket is taken multiple depths. And if I zoom in down here at the bottom, you'll see a little 10,000 step down at the very bottom of each of these, because I told it I wanted to do a 10,000 cleanup pass. One thing I want to do here, I do want to go to my heights page. I don't want this machining to take place from the top of stock. I want to start at the model top because I've already faced off the top of the part. So just a minor change there. And now I've got some pocket milling. And I could simulate that if you wanted to see it. Now this is what I wanted to talk about here a little bit. You'll notice with these particular pockets, as that tool gets down here in the corner, notice it's completely going to bury that tool. It's about half the tool there. It's going to bury it right here in this corner. When it comes around, it's going to bury it in this corner. With traditional pocket milling, which is what most CAM softwares give you, is you're going to end up getting buried in the corners. If I were to take that pocket mill, instead of doing a pocket, I'm going to use the 2D adaptive. Same tool, same selections. Say OK. It is going back to the defaults. Let me make a couple quick changes. I do want to take off the helix and put in a plunge. I'm going to go to depths. And I'm going to tell it no stock, multiple depths. I want to take 100 at a time. Just to be fair, I'm making it exactly the same as the other one. I'm going to edit that, go to my heights page until I want to start at the model top instead of the top of the stock. Now, I showed you a quick simulate on the other one. I'm going to simulate this real quick. This time, that first cut looks heavy. Let me stop here a second. I'm going to do the face and the adaptive. I'm going to simulate both of those together. I want to get the top of the part cleared off. That was the face mill. I just bypassed it real quick. I'm going to hit play here. So I want to watch the cutter and how it approaches this pocket. Yes, I did tell it to plunge. I know some people don't like plunging, but notice the spiral approach. You have a certain chip load on that tool. As it gets into the corners, it's not diving into those sharp corners anymore. See it taking the sweep or large circular approach to cut that out? At no point in time does it ever get buried into those corners. It's just going to repeat that layer by layer. Same thing here on this middle pocket. It's going to come around in a circular motion. As it starts bumping the walls, you'll see it start machining around the walls. But to get into those tight corners, see the sweeping action it's doing? You can run this at high speed and not have to slow it down for anything. That's what they call adaptive milling. It's a very powerful feature, and I'm very happy to say we're about the only software in the market that even has something like this. Now, once you have your machining done, you can do a quick setup sheet. We'll save this to the desktop. It gives you a nice little program comment, job description, what the name of the part is, tells you what size stock, how big your part is, everything about your setup. I've got 3 operations, 1 tool. Not sure why I say 1 tool, because there are obviously 2 tools. But it gives you a listing of your tools that are being used and the different operations that are being handled. It's giving me 1 tool because I have them all labeled as tool 2. So I need to go back and change one of those to some other tool. But you've got free setup sheets. All you got to do is click a button. Let me edit that. That should be tool number 1. Okay, quick tool change. Again, you got a setup sheet if you want to process it for your machines. Just tell it what machine you want to go to. I've got a Fanuc selected here. I post it out, save the NC program. It actually launches your editor. I mentioned earlier, you get a full-fledged color-coded editor, which makes looking at and editing your code pretty easy. Now, that's a quick rundown. I know this is a short seminar, so I'm going to try to get to the point here. I don't have time to machine the whole part because an hour is just not much time. But I want to show you some other things about this just to prove we're not a lightweight program. You know, anybody can machine a 2.5 axis part. You get into things like 3-axis cavities. This has got a lot of unique things in it. It's got a block stuck in the middle of it. It's kind of a revolved part. It's open on the ends. People always ask, how do you handle openings on the ends? I've got my setup here. It's just a piece of stock. But to show you some shortcuts that are available, if I say create from template and do a face mill, last time I did a face mill, I went through the whole dialog box and I chose my settings. Once you get your settings the way you prefer it, like I like to do multiple laps, certain amount of step over, I can save those as templates so I don't have to use factory default settings. So there's the face mill for the top of this part. Create from template. I want to do an adaptive roughing. We'll just go ahead and generate that toolpath. And we'll take a look at this in the simulator. It'll make a whole lot more sense when you do that. Create from template, parallel lace mill. Parallel lace is kind of a zigzag machine. It's supposed to look like shoelaces on your shoe. Let me just edit that. I do want to put these two in as avoid touch surfaces. Now, I've got this choked down. And I'll show you where that is. I'm only telling it to go 45 degrees worth. So it's going from 0 to 45. Because I didn't want to machine the whole sidewall with this toolpath. I just wanted it to machine the bottom area. And I'm doing the same thing on the next one, create from template, what they call a contour machining. Contour is what a lot of softwares call waterline machining, where you approach everything from a top-down approach. Again, I told it there's no need to go past that 45-degree mark because the other toolpath is going to cover the other half of the part. So because contour machining works best with steep walls and parallel machining works best with flatter walls, I can combine the two together to machine the vertical and flat walls and get the ultimate cut by just separating the toolpaths into two pieces. And just to show that we can, let's do a little pencil mill here real quick, generate that toolpath. That one will take a little bit to crunch. I've got a lot of rules set up in that pencil mill to do certain things, and I want it to look a certain way. You can see it's basically using a smaller tool to get into those tighter grooves and corners around the base of that. But to look at this from a machining point of view, hit play on that. You can see very quickly I'm using that big old 2-inch shell cutter to face the top of this. We do that in 2 passes. Here's that adaptive roughing. Trying to get it in good and close so you can see it. Again, not at any point in time does it bury that tool. Anytime it sees a corner or place where it can get in trouble, it starts swiping at it. Again, it's to maintain that chip load and to save the wear and tear on your tool. Now, this particular toolpath, it's going to look like it's doing some extra running around at the top when it's done. I'm doing a major step down and I'm also doing a minor step down. I haven't seen a lot of softwares that do dual step downs. And I'll try to explain this as it gets deeper. As it gets deeper and gets into the more curved areas at the bottom, you'll be able to see what that's doing. Let me get some of this toolpath out of the way here. Let's just go to tail mode. But see that step over there on the wall? Because I went down, I forgot 1/8 of an inch, I think is what I'm cutting with this tool. As you go down 1/8 of an inch, it kind of leaves a step there along that sidewall. You can see it more here on this curvature. What I'm doing with that minor step down is it comes back and takes pass 1. I told it to take 4 additional passes. There's pass 2. Sorry, 3 additional passes to make 4 steps. And there's pass 3. But see how I eliminated that step that was there? I go in a little bit deeper. Try to speed this up a little bit. Again, there's the original rough, and here's those 3 extra passes I'm taking. Because I don't want to come in here with a small finishing cutter and be hitting those stair steps on that sidewall. By taking just a few sidewall passes, I'm eliminating those giant stair steps where my finish cutter is not going to be quite as affected by the stair steps that are going on. Go ahead and machine nail that down. Even here, that ledge was too shallow in here to run the tool all the way through. That's okay, because these stair step paths I was talking about, they'll actually get that on the stair step path. So not only is it knocking off the wall on the sidewall, it's actually getting your roughing down a little bit closer to the actual part. One more pass here. And then it goes into the deeper area. Okay, so here's the finish pass hanging off. Here's the lace mill I started with. You can basically just say it's walking back and forth. And those little stair steps that I left are going to do nothing to this tool. It's a piece of cake. So just by having a few extra passes on my roughing, I'm saving, actually I'm able to run my finish pass a lot faster now. I'm running out of time, so I'm going to try to speed some of this up. Again, that's the lace mill. It's just doing a back and forth process. When that's done, it's going to start doing the contouring, which is what we call the water line. Going around the top of the part, row by row. I've got a fairly fine step down because when you're machining in real life, you use fine step downs to get smoother finishes. As a pattern maker, I had to polish a lot of my work, so the more I could do with the tool, the less sanding I had to do when it got to the polishing bench. So I am used to fairly small step downs. But notice, even though I told it to stop at 45 degrees, it's still going to go deeper because even these grooves and stuff have vertical sidewalls. And then I've got that pencil milling that's going to come in. See if I can get in here. Let's do this. Let's hide the holder real quick. You can actually see the tool. You've got all kinds of visibility settings in here. Notice on that pencil milling, it's just slowly stepping into that slot from each side, working its way towards the middle. So you should be able to eliminate any kind of whiplash with the tool by using their pencil cycles. Their pencil cycles start at the outside and work their way into the corners. I think you'll be able to see it on this radius. See, it's kind of on the outside. It's going to work its way towards the corner. It's also going to work it from both sides, the vertical side and the wall side. You might be able to see it more over there. Maybe not quite so much. Yeah, you can see it working from the floor side there. Then eventually it's going to come in and start working it from the wall side. I don't know if the web's keeping up with this simulation. I hope it is. But you get the idea. Pencil milling is very strong in this program. But it gives you an example of full 5-axis or 3.5 or full 3-axis machining. Again, I can do a quick setup sheet. There's my setup. There's my tally. There's a listing of all my tools and what tool is doing each operation. These are great. You just print them, hand them to the operator. The operator goes out and runs it. He's got everything he needs to run that program. Again, post-process it. You grab whatever tool you're going to send it to, post it out. I'm going to overwrite the program I did a little bit ago. You see your code, got all my comments in it. There's my face mill, there's my adaptive roughing, so on and so forth. Now, because HSM can also do lathes and full 5-axis, I brought this part up because it has everything in it. Okay, it is a turned part, but notice we have all kinds of stuff on this part. I've got a drill in the center. I've got drills that are offset. I've got drills that are radial. I've got pockets to be machined from the end view. I've got pockets to machine from the side view. I even have pockets that are on a different CNY axis with a drill in the middle of that pocket at a different CNY axis. We tried to pick a part that has a little bit of everything in it. But just give you an example, I'm going to grab the whole setup and say simulate this. This is a turn part. So again, first operation I did was a facing. So I'm just taking off the facing. I followed that with a basic turn roughing, which is pretty much the way anybody would run a lathe. Standard roughing off the side. When it gets done with roughing on the side, I actually have a finish pass that does the front and the side all together. Here's my finish pass. I come back to the grooving tool, punch the groove in there. Here I'm doing some end milling. So this would require a CNY axis machine. There's a center drill, and here's your offset holes. Again, all coming from the end. There's some machining from the end. I took 4 passes in each one of those. There's the machining from the side. Let me pause this for just a second. Give it a second. Anytime you pause it and get it going again, it takes a while to catch up to where it was. And here we go. So you can see I'm doing some machining in there. Then we've got some axial drilling. Or sorry, not axial, rotational drilling. There's that crooked cut with the crooked drill. And there's actually a 5-axis swarf doing that other side. Now let me get to the other end. Now on this, we also handle multi-spindle. So I cut the front half of the part with the main spindle. What you're seeing here is everything being cut from the secondary spindle. The exact same set of tool paths being cut with the secondary versus the primary. So again, as far as lathes go, we do full CNY axis milling. We do primary and secondary spindles. Just about everything you would need on the lathe side of the world. And yes, these cuts are basically the exact same cuts that are happening on the other side. There's that little pocket mill. There's your rotational drilling. There's this crooked cut with the crooked drill, and there's the 5-axis swarf again. And just to give you an idea of what that looks like. These little dimples here, it's basically almost like a chamfer, but they left a dimple to leave room for clearance for these holes. So not only do you have a chamfer, you got the little dimple. That is pretty much really hard to do without having full 5-axis capabilities. But that's why we used a 5-axis swarf here on the end, just to show as much capability as we could. And unfortunately, it looks like it's 12 o'clock and I'm running out of time. I see not a whole lot of questions coming in. As you can tell, hopefully this software is fairly easy to pick up on and fairly easy to run. It is a full capability software. I tried to select some parts that actually showed it is fully capable of just about anything you want to throw at it. So it's not just some little lightweight add-in that was thrown into Inventor. It's a full-fledged machining package inside Inventor. So hopefully I answered those questions for you guys.
Let's see. Looks like one question's come in, Clayton.
I just read that. I recently purchased a Haas CNC milling machine with a likely older software. Even though they classify this as high-speed machining, a lot of what they do in the post-processors go back easily 50 years as far as machine controls. So I would not be worried at all about an older controller. No concerns at all.
Let's see here. I'm also going to put in that post library that you mentioned. This link that I'm sending is actually in the software. Let's see. I'll put that on Ron's question and send to all. So yeah, you can go there and
process. Right here, if you're in the software, I'm showing it right now on the screen. If you're in the software, when you go to post-process, if you can't find your controller on the list, again, there's several of them here. Just kind of let you guys scroll that list a little bit. If you don't see it on, you know, there's over 100 here, I think. There's quite a list. If you don't see it anywhere on this list, just click right here. It will take you to their website. On their website, you can say, okay, I've got a turning machine. It happens to be a Centroid. Of course, I would pick the one. Let's say it's an old Bridgeport. Oh, Bridgeport is milling. But, you know, just even Bridgeport DX32, Easy Track Conversational. They have a lot here, and it's searchable by vendor. You know, if you have a Doosan, for an example, there's several out here. There's a Doosan with Fanuc 331i controller, a Doosan 3 5-axis with a VMC Fanuc controller. So there's a lot of them out there. If you don't see the one you want, Autodesk also have others that they're developing that may not be on the website yet. So
absolutely. How does it work with a wire?
Yeah, how does this work with programming for a wire burner? I didn't show any cutting. To be honest with you, when I first got into machining softwares, I did pocket milling and profile milling, and I just put the tool diameters the size of the wire. HSM makes it so much easier than that because they do have what they call cutting now, which incorporates all cutting, which is lasers, plasmas, water jets. So a wire burner, I'm assuming would fall into the cutting category. I would have to check to see if they have the 4-axis cutting. That's something I'd probably have to look into. Is there any integrated communication to send to the G-code to the machines? Yes, there is, absolutely. I did not show that. It's not a big common question, but yes, it is built in with the package. Used with Vault Pro or Basic for file control. Yes, your file, any of these files you're looking at here, like this one that has all this machining in it, when I hit save, you're saving an Inventor part file. All the tool pathing, all the setup is stored inside the part file. So you're not storing additional files, you're just storing your part like you always have with Vault Basic or Vault Pro. Good questions, guys. I like your questions.
Yep.
I guess I like them because I haven't had to say no to any of them yet.
Very good. Any more questions?
Well, we want to thank you all for attending. I don't see any others rolling in, but I was going to start some closure here. Thank you for all. Thank you for attending. Obviously, you can get a hold of your salespeople for any questions you might have. If you want to know something that you did not see in the webinar, feel free to call your salesperson and just give them the question. Kevin's around. I'm around. We're always around to answer any questions that might come in. Paul has a great question. Speeds and feeds are associated with the tool. How does the tool type, how does the type of material enter into that equation? Just to give you an example, let me bring this guy back up again. I don't think I saved it. But when you go to your tool library, let's just do a face mill. Go into your tool library. The best bet here, I tell people, and I know I'm getting in overtime here, they give you hundreds and hundreds of samples. And you might notice their sample libraries are set up per material. So if I go to inch brass and take a look at, end mills are going to be down at the bottom. Let's say a 1-inch end mill. That tool is going to have certain feeds and speeds built into it for that material. If I come back in here, I think last time I went to brass, let's say I go to high carbon steel, I can grab that same 1-inch end mill, and your feeds and speeds are now according to that material. And it's so easy to build your own libraries for your materials. Basically, just take a copy of their library and put your own feeds and speeds in for each material that you might use in-house. Hopefully that answers that question.
Very good.
Yeah, all good questions, guys. Great feedback. All right. I don't see anything else coming in. So Ashley, I think we'll go ahead and close this out. Again, if anybody has questions, feel free to call our salespeople and they can get answers for you.
Yes, thank you, Clayton. And thank you everyone for attending and your interest. A reminder, you will receive an email tomorrow with the link of today's recording. And that takes care of that. So thanks everybody and have a great day.